right, here is the next shape that we're going to work on finding the surface area of. We're looking for the surface area of a cone. A cone is a solid shape that has a circular base, but then it comes to a vertex, which is not on the same plane as the base. So it's always going to come up to a point. Think of it as an ice cream cone or a party hat. That's the kind of shape we're looking at for a cone. So the slant height is a new term for today. Slant height is going to be super important because you need to know the difference between the slant height and the regular height to be able to find the surface area and later the volume correctly. So slant height is the segment that connects the vertex to a point on the edge of a circle. So it's a lot of words there. But if you look at, there's two things that come from the vertex. We have this line, I'm going to make it red, and then we have this line that I'm going to make blue. If you look at them, one of them is straight up and down and one of them is slanted. The one that's slanted is the one that we're going to call the slant height. That one happens to be on the outside of the cone. That's where the slant height will always be for a cone. And then this one that's going straight up and down, that's actually the actual height. If we want to know how tall it was, that's the number we'd be looking for. And then there's one other part that's important in our cone. It's that bottom line of that triangle. That's going to be the radius of the circle. So that'll be the radius. Okay. Just letter-wise, when we talk about height, we use the letter H. When we talk about slant height, we use the letter L. So just so you see that difference. Because if you look at the surface area formula, there's just two letters we need to know. We need to know R, which we know is the radius. And we need to know L, which the L here is going to stand for the slant height. So what's going to be tricky in some of these problems is sometimes the slant height is not given to you, and you need to find it, which is what we're going to actually talk about first. So these first two examples, we just want to work on finding the slant height. So first off, if you're looking at the picture in number 1, I'm going to highlight that this is the side we want. That's L. So we need to find L right now. In order to do that, we have to use what they gave us to come up with the information we need to figure out that missing piece. What we really want to focus in on here is we want to locate the triangle that it's a part of, and we can use that has a right angle in it, is we can use a squared plus b squared equals c squared. Since it's a right triangle, we can use Pythagorean theorem. You just need to make sure you're using the correct numbers. The 42 is not part of the triangle right now, so we need to actually cut that in half and find the radius so we can use the appropriate number. So this ends up being 21. So then we're just going to do a squared plus b squared, that's the 2 legs squared, equal to the hypotenuse squared, L squared. And then 20 squared is 400, 21 squared is 441, equal to L squared. We get 841 equals L squared, and we take the square root, and you should get that L is 29. So then looking at 2, same kind of idea is we want to make sure we know the slant height. Right now the 7.5 is on the real height. The slant height would be this side. You could also do the other side, but there's no numbers on that side, so stick with the side that has numbers on it. I'm going to call that L. And then we're going to focus in on this triangle. For this particular triangle, all the numbers we need are already there, so we're just going to jump right away to a squared plus b squared equals c squared. And you're going to do 4 squared plus 7.5 squared equals L squared. And that's going to be 16 plus 7.5 squared is 56.25 equals L squared. That's 72.25 equals L squared. And then we're going to take the square root. And you end up with L is equal to 8.5. Okay? So some of the problems are going to require you to do that, some of them won't. You just have to pay attention to if they gave you the slant height or not. If they gave you the slant height already, just use it. If they didn't give you the slant height, you're going to have to do Pythagorean theorem to figure it out. So looking at this next example, we actually do want to find the surface area. I'm going to write out our formula first. The formula is pi RL plus pi r squared. So the two things we need to know from the picture is we need to know R and we need to know L. R is going to be the radius of the circle. So it's going to be this bottom number here that's going to be 3. And L is the slant height, which would be this outside line we want right now, which they are telling us the measurement of. L is going to be 8. So we're going to do pi times 3 times 8 plus pi times 3 squared. And these are very similar to the cylinder. We're going to multiply first. We get 24 pi. And then 3 squared is 9. That's 9 pi. Then we're just going to leave this in pi form. So you just got to add those together. You get 33 pi inches squared. Okay? So here we go, number 2, same formula. I'm just going to write it down over here, pi RL plus pi R squared. So those are the two things we need to know from the picture. We need to know R, we need to know L. So if I'm looking at the picture, R is definitely 5. L, though, we do not have this time. L would be this side over here. I do not know what L is, so I need to use Pythagorean theorem to figure it out. So I'm just going to do that over here on the side. A squared plus B squared equals C squared. That's going to be 5 squared plus 12 squared equals L squared. We get 25 plus 144 equals L squared. 169 equals L squared, and take the square root. L ends up being 13. So you need to make sure you're using the appropriate number. If the slant height is missing, we find it first. And now we can just plug into the formula. That's pi times 5 times 13 plus pi times 5 squared. That's going to be 65 pi plus 25 pi, which gives me a surface area of 90 pi centimeters squared. All right, let's take a look at number 2. Again, I'm going to write down we need to know R, we need to know L. And number 2, the radius is on the circle. We need to know how long that is. That's going to be half of 20. The radius will be 10. And then L, again, is not given to you. L is this line. The 24 is pointing to the line on the inside. The slant height will always be the line on the outside of the cone. So we need that outside line. That's L. Which means, again, we have to do Pythagorean theorem. We're going to do a squared plus b squared equals c squared. And that's going to be 10 squared plus 24 squared equal to L squared. So we get 100 plus 576 equals L squared. That's 676 equals L squared. And take the square root. And this happens to come out to a nice number, 26. Sometimes it might come out to be a decimal number. The directions are just going to ask you to round to the nearest tenth. So don't be shocked if there's a couple on the homework that give you a decimal, just round it. And now we just have to plug those correct numbers into the formula. So the radius is 10 and the slant height, L, was the 26 that we just found. And then that's plus pi times 10 squared. So we get 260 pi plus 100 pi, which is 360 pi. And then let's put those units on there, inches squared, since we're finding area. Okay, so there's a couple problems for you to try in class kick, just to make sure you're understanding this correctly. And then you do have a couple of homework problems as well. It's not a lot, so if you're working effectively, there's no reason you can't get all of it done during class time, and then you can enjoy your weekend.